Okay, so in this video, we're going to do a brief review of features of power functions. Now, a power function is anything of the form that is written here, where you have a bracket x minus h to the power of n plus k. Regardless of what n is, that is a power function form. And these letters h and k are important letters for us on all the different kinds of power functions because it always means something. So let's look at a few different cases. First of all, it's positive and even, the power of n. So that'd be something like a quadratic. You have a x minus h squared. Whoops, that's squared should be outside the bracket, plus k. Or a quartic, a x take h to the power of 4 plus k. In this case, this h, k together form the turning point of the graph. So if I end up drawing the graph, the quadratic looking something like this, you have a quartic looking something a bit more like this, but they both have a turning point of hk. This a at the front, if it's positive, they'll be upright. If it's less than 0, so negative, it'll be inverted. The value of the k there is simply your vertical translation. If you have n being odd, that's something like a x take h to the power of 3 plus k, or to the power of 5 or anything like that. Now, I've deliberately not used n equals 1 because n equals 1 just becomes a nice linear equation. But if I have anything other than 1 that is positive and odd, you'll end up with an inflection point occurring at hk, a stationary point of inflection. Okay, so you'll end up with, oops, that's not very straight, but you'll end up with a cubic looking like this. So cubics come up and they flatten out there and they keep going. Now, a power of 5 graph climbs more quickly here, but then flattens out a lot flatter and then climbs more quickly than a cubic would and continues on. Okay, but you end up with an inflection point, stationary point of inflection where the derivative is 0 at hk. Again, a being positive means it's going from bottom left to top right. A being negative means you're inverted, going from top left down to bottom right. And again, the k is your vertical translation. Now, if n is negative and some form of integer, so I should write negative integer here, then hk does not form a coordinate. This would be something like f of x equals a x minus h to the power of -1 plus k. Now, in this particular case, you're not going to have a coordinate forming for hk. What you find is you'll have x equals h is a vertical asymptote, and you'll have y equals k is a horizontal asymptote. So taking my example that I've just written, that is a hyperbola. So power of -1, and you end up with a vertical asymptote there and a horizontal asymptote happening there. That happens for anything with a negative integer. Now, if you have a negative odd integer like -1, -3, -5, you're going to end up with something looking like this for your graph. So you have x equals h there, y equals k there for your horizontal and vertical asymptotes. If you have -2, -4, -6, and so forth, you'll end up with something that looks like this, a truncus. It's supposed to be symmetrical around, but the vertical and horizontal asymptotes remain the same. Of course, if a is negative, the green one flips down. And of course, if a is negative, blue one would become like that, so new regular transformations. Two more cases are where you get fractions with even and odd denominators. Now, first one is even denominators. That'd be something like f of x equals a x take h to the power of a half plus k, which is really a square root graph. Now, with square root graphs, they have an endpoint of hk. And that is a point where that if you were to look at the graph, the derivative will become vertical. The gradient becomes vertical. So if I look at a square root graph here, this thing here is like a turning point of a quadratic. I can put it there, I can put it a bit higher, doesn't really matter, I can put it there. This is like a quadratic turning point because really a square root graph is a sideways parabola. Now a parabola has a gradient of 0, so in the inverse, which is what a square root graph really is, it goes vertical, so it's undefined at that point. And an even denominator would normally cause it to come back this way, but we can't do that because it's not a function in that case. So hk becomes an endpoint in these cases. Of course, if a is negative, it flips it down, going that way. And k is your vertical translation, so it's an endpoint. But with an odd denominator, so something like the power of 1/3, that would be like our cube root graph. It doesn't form an endpoint, but it forms another kind of inflection point. Well, it's analogous to the inflection point for your cubic, anyway. Because when we draw this graph, it is an inverse of a cubic, so it goes vertical just that little bit there and continues on. So the point where it goes vertical, where the gradient becomes undefined, is at hk. So I'm not entirely sure it's called an inflection point. We're going to call it that for now. It's hk. So this coordinate hk, these values hk either form coordinates or they form asymptotes of anything written in the form f of x equals a x take h to the power of n plus k, and hopefully that gives you a good idea of which one produce which kind of point, asymptotes or intercepts, so asymptotes, endpoints or inflection points, stationary points.